Welcome and good afternoon. Graduates and guests, you may be seated. My name is Martin Olson, and I'm the chair of the Department of Mathematics. It is my honor to welcome you to today's celebration. Let me start by welcoming and congratulating the graduating students. Each of you have had your own unique experience in our programs. You come from many different backgrounds and have found your own path and succeeded in our demanding undergraduate and graduate programs. Today, we celebrate you and all that you have accomplished. I also want to note that a number of graduate students here today did not have in-person college graduation, and many of our finishing undergraduates did not have an in-person high school graduation. So this is an especially significant ceremony for them. Faculty and guests, please join me in congratulating our graduating students. You have not reached this important milestone alone. I would like to acknowledge and thank the parents, spouses, grandparents, families, significant others, and friends who have been so instrumental in the success we're celebrating today. Graduates, please join me in acknowledging and thanking them for all their support. Graduates, your connection to our department and university does not end today. You're joining our vast community of alumni from UC Berkeley, some of whom are here today. If you're a Cal alumnus or alumna, please stand. Thank you for coming today, and thank you for supporting our graduates. Graduates, you have earned a degree in a very challenging subject at one of the world's premier universities. I'm proud to be a member of this department and proud of the public nature of this university. I hope you are too. Each of you has had a different journey through our program and university, and the experience of mathematics is different for each of you. Mathematics is a vast field, including both pure and applied aspects. During your time here, you may have studied analysis, topology, probability, number theory, optimization, logic, just to name a few topics. Through your studies, you have engaged with different parts of the field. The details differ for each of you. Our modern world is heavily mathematical, even if people don't always realize it, and that will surely continue to be true in the future. Advanced mathematics is playing an ever-increasing role in a wide range of careers and daily life. Beyond the specific mathematical topics you have been taught, you have learned skills that prepare you for that future and extend beyond mathematics. Clear thinking, reasoning, writing rigorous arguments, and skills for creatively and systematically attacking complex problems. You carry your degree into a world facing enormous challenges. Many of you will never take another midterm or final. Okay. That was actually the easy part. Some of you will continue in academic careers in mathematics, teaching, and research. Others will put mathematics and mathematical skills to work in business, engineering, and in other branches of science. Some of you will pursue careers that seem to involve little or no mathematics at all. Regardless, over time, you will probably forget the details of some of the mathematical definitions, theorems, and proofs that you studied. Eventually, you might not even remember exactly which courses you took. The value of your mathematics education is in how it has prepared you to take on some of the most significant challenges of our time, which require the kind of deep mathematical reasoning skills that you have acquired. The obstacles may seem daunting, but your abilities and character bring me great optimism that we will meet the challenges ahead. I hope that you will remember your time as a student here with fondness. In addition to learning mathematics, you have made connections with your fellow students and with the faculty and staff in the department that I hope you will treasure for the rest of your life. We always enjoy hearing from past graduates, so please keep in touch. Please stay engaged with mathematics and with the mathematics department at Berkeley. Congratulations to you all. I now have the distinct pleasure to introduce the Dean of the College of Letters and Science, Mathematical and Physical Sciences Division, Dean Steve Kahn.
So thank you, Martin. Let me also take this opportunity to personally congratulate our graduates and to welcome our many guests who have come to campus to celebrate with us. The most enjoyable element of being a faculty member at Berkeley is the opportunity to interact with our wonderful students. Our undergraduates at Berkeley are enormously diverse. They come from a rich variety of backgrounds and bring a wealth of fresh ideas and perspectives to our classes. The chance to expose these students to some of the most intricate concepts in the mathematical and physical sciences for the first time is incredible. There is no other word to describe it. Our graduate students are among the most brilliant young mathematicians in the world. As you are probably aware, mathematicians often make their most significant and fundamental contributions to the field at a relatively young age. The PhD recipients you will see hooded today have already made their individual marks on their disciplines, and we are confident that they will go on to illustrious careers. The past few years have been trying for our students and faculty as well in many respects, and the past year has been especially worrying. It seems clear that intellectual pursuits of all kinds are under attack, and many in our country now need to be convinced of the value of pure research. Mathematics is an esoteric subject, and its inherent beauty and profundity may not be evident to the general public. The advance of AI has also called into question what elements of the field require uniquely human creativity and insight. As you move forward with your careers, I hope that you, our students, can be ambassadors for your chosen field. The notion that abstract and strange concepts can be unambiguously proved is quite foreign to many in our society. The intellectual rigor that is required to master modern mathematical coursework is underappreciated generally. Today we have the opportunity to celebrate your achievements with your family, friends, and colleagues, and I'm very proud and happy to be able to share in that. Let me close by thanking our faculty and staff in the math department who are truly amazing. As Dean, I'm especially appreciative of your department chair, who you heard from earlier, Martin Olson. He's been a delight to work with. Martin took on the chairship 2 years ago, has done a fantastic job keeping the department together and functioning well. Thank you, Martin. And congratulations once again to all of our graduates.
Thank you, Dean Kahn. We now turn to the recognition of undergraduate honors and awards. Professor Richard Bamler, Vice Chair for Undergraduate Affairs, will assist me. Prize winners, when called, please rise to receive your certificate and then be seated. The Departmental Citation and Paul Chernoff Memorial Prize. Each year, the Department of Mathematics awards its departmental citation to the top mathematics scholar in the graduating class. The citation winner will be presented with a certificate signed by the department chair and the chancellor of the campus. The departmental citation winner is also presented with the Paul Chernoff Memorial Prize for Extraordinary Scholarship in Mathematics. The Chernoff Prize was established in memory of Paul Chernoff by his brother Donald Chernoff. The 2025-26 citation winner and Chernoff Award winner is David Jung. The Dorothea Klumpke Roberts Prize in Mathematics. The Dorothea Klumpke Roberts Prize was established by Mrs. Dorothea Klumpke Roberts, astronomer, in honor of her parents and husband. It consists of a cash award to a senior or seniors who have demonstrated truly exceptional scholarship in mathematics. The 2025-26 prizes are given to Declan Carl Hoban, Yoon Sang Kim, Brian Lee, Tristan Liu, the Percy Lionel Davis Award for Excellence in Scholarship in Mathematics. The Percy Lionel Davis Award was established by the daughter of Percy Lionel Davis in honor of her father, a Cal graduate in engineering from the class of 1913. It consists of a cash prize to her senior or seniors who have demonstrated excellent scholarship in mathematics. The 2025-26 awards are given to Neil Nitin Agrawal, Daniel Au, Drisana Bhatia, Si Yen Chen, Jason Guo, Athraya Kadambi, Jack Lipson, Sushant Satish Kumar, Liam Tan, winners of the 2025-26 Percy Lionel Davis Prize who could not join us today are Kyle Fenimore, Tyler Hu, Jackson Patrick Coos Davis, Jungmin Park, and Atharv Sampath. Thank you, Professor Bamler. The honors program. The Department of Mathematics has an undergraduate honors program. In short, to be an honors student, one must maintain an exceptional grade point average and must either write an honors thesis or complete 2 graduate courses with excellent performance. We will recognize those students graduating with honors as we present them with their scrolls later in the ceremony. But now, let us congratulate all these candidates for their exceptional achievement. At this point, I would like to introduce this year's valedictorian, David Jung, who graduated in fall 2025 with a double major in mathematics and computer science, achieving highest honors and highest distinction in general scholarship. With a perfect 4.0 GPA, the Mathematics Prize Committee unanimously selected David for the Department Citation Award and Paul Chernoff Memorial Prize. One professor highlighted David's notable intellectual curiosity and ability to make connections. Faculty are also impressed by his good questions, his excellent communication, and his ability to learn an impressive amount of material over short periods of time. We expect him to make meaningful research contributions in whatever area he chooses to study in the near future. We are pleased to share that David will continue his mathematical journey next year by starting a PhD program in mathematics at Harvard. David, the podium is yours.
Thank you, Professor Olson, for the introduction, and thanks to the Math Department for this award. It is an honor to have been selected for this distinction. Throughout my academic journey, I've had the generous support of so many people. I'd like to thank my professors for their guidance and patience, and I'd like to thank my friends and family for their love and encouragement, especially in times of self-doubt. Indeed, I must say that my past self would be shocked to see that I'm here at this particular commencement. When I first arrived at Berkeley, I had zero intention of pursuing mathematics. The childhood memory that best represents my past experience with math has me crying tears over a workbook and ripping out the pages in frustration. I never considered myself a math person, and I realize now it's because I never saw the point of it back then, only as a means, as an end to other things. What I ended up finding so beautiful about math is perhaps best captured in the words of another. There was an artist, Brian Charnley, who characterized painting in a way that sounds exactly like mathematics to me. Quote, "One is very much up against the almost impossible task of describing in paint that which is essentially totally invisible. Symbols come to be employed, and the appropriate one must be found. Also, it should have a poetic charge attached to it." In our subject, we begin painting a world of mathematical truth by first isolating the key elements. These are our definitions. We study the interactions between them, depicting scenes of them playing together in the hope that the images coalesce into a deep result. At last, a landscape. Grass grows, birds fly, sun shines, and x to the n plus y to the n equals z to the n has no non-trivial integer solutions for n at least 3. You can already picture the first 3 scenes, I imagine, but for the last, I do have a proof you can paint it, but it was too long to fit into the margins of my speech. By examining logical structure in this way, we are awarded with an ironclad understanding of whatever our theory is about, and for any situation where the definitions and hypotheses fit, we may reap the logical consequences of whatever we have proven. As mathematicians, we know better than anyone these themes that are most appealing and most powerful about our subject. But we should also know better than anyone the inherent limitations of our discipline, especially in its application to the real world. In everyday life and in our institutions, it seems an ever-pervasive trend to put metrics on everything. Because once you quantify all these things, you can try optimizing for this and that, and apparently that leads you to victory. But this mindset doesn't sit quite right with my mathematical intuition, because I know that not every topological space is metrizable. In the same vein, not every algebraic variety is affine, not every poset is totally ordered, and not every group is abelian. What I mean is that in order to faithfully capture whatever structure you have by a suite of metrics, you must be making some important assumptions on whatever it is you're analyzing. Assumptions that just don't hold up for a lot of themes. After all, real life is so much more complicated than the landscape of known mathematical results. I mean, it's crazy how little we really understand about math in more than 2 dimensions. And while I don't know much about physics, I'm pretty sure we live in at least 3 dimensions. These assumptions matter because the deductive reasoning that powers the mathematical machine is only as bulletproof as the assumptions you start with. But I get it. It's so tempting to put numbers on things. Numbers have a certain authority to them. You can point at a number and say that since it went up, things must be going good. But as people with the training to know when the math falls short, we must be responsible with how we and how others wield it. Now, you might be thinking to yourself, dang, then what was all this for then? I spent all these years sweating in Evans and Echeverry, and now you're telling me math might not even be what I need? But don't forget, math is not just beautiful, it's unique in its level of rigor. Through our studies, we build up that mental game, which I think is important, though some would now have you believe that these thinking skills are not so critical anymore. Only time will tell, but what I do know is that by studying this one-of-a-kind subject, we've become hardened problem solvers who know when math fits in our toolkit, and most of all, who have the thinking skills to adapt to whatever the times of today throw at us. And believe me, they're gonna throw a lot at us. But we got it, because we like that, you know what I'm saying? So let's celebrate this achievement. Congrats to the class of 26. Yay!
Thank you, David. Next, we recognize the winners of the Graduate Student Awards. Professor Thomas Scanlon will assist me. The Kenneth Ribbett and Lisa Goldberg Award in Mathematics. This prize has been established in honor of Kenneth Ribbett and Lisa Goldberg by the family of Professor Ribbett. A cash prize is awarded each year to a graduate student in the Department of Mathematics whose research focus is in number theory or another branch of algebra. Recipients are selected for exceptional work, which may be completed work or work in progress. The 2025-26 awards are given to Fangu Chen, Daigo Ito, and Feya Lin. The Herb Alexander Prize in Pure Mathematics. This prize was established in the memory of Herb Alexander, an internationally recognized mathematician and a much-loved husband and father who died from cancer in 1999 at the age of 58. Professor Alexander received his PhD from Berkeley in 1968 under the supervision of Hans Bremermann and Don Saracen. Inspired by Professor Alexander's fond memories of his time here at Berkeley, a cash prize is awarded for an outstanding dissertation in pure mathematics. The 2025-26 awards are given to Carlos Esparza Sanchez, and Ellie Sandin. As well as Chiyu Ren, who could not join us today. The Bernard Friedman Memorial Prize in Applied Mathematics. This cash prize was established in 1966 as a memorial to Bernard Friedman, a distinguished applied mathematician and the 9th chair of the Department of Mathematics. The department presents this prize to honor outstanding dissertations in applied mathematics. The winners of the Friedman Prize graduating today are Zhen Huang, and Louis Penn. The winners of the 2025-26 Friedman Prize who could not join us today are Yang Chu, Gil Goldschlager, and Gabriel Raposo. Next, we present the teaching awards. The Nikki Kosei Memorial Teaching Prize. This prize was established in 1981 as a memorial to Nariaki Kosei, a graduate student from Japan who passed away in a mountaineering accident in the summer of 1980. A cash prize is awarded to a graduate student instructor in mathematics for truly exceptional teaching performance. The 2025-26 winners of the Nikki Kosei Memorial Teaching Prize are Isabel Dethridge, Mitsuki Hanada, and Siwoo Lee. Thank you, Professor Scanlon. Next, we would like to recognize our extraordinary graduate student instructors. The Outstanding Graduate Student Instructor Award. The Outstanding Graduate Student Instructor Awards are presented by the Committee on Teaching of the Berkeley Division of the Academic Senate to those graduate student instructors and undergraduate student instructors who have demonstrated exceptional teaching ability. The following graduates have received this award during their academic careers here. After I read the list, I will ask all these students to stand and to accept your congratulations. Caitlin Berlow, Drisana Bhatia, Isabel Dethridge, Carlos Esparza Sanchez, Sean Gonzalez, Connor Halleck Dubé, Mitsuki Hanada, Eric Jankowski, Siwoo Lee, Brian Lee, Rose Eleanor Lopez, Louis Pan, Zachary Steyer, Rebecca Whitman. Will you please stand? The Distinguished Undergraduate Teaching Award. This award is particularly meaningful because it comes from students. It was established in 1983 by the Mathematics Undergraduate Student Association, known as MUSA. The graduating class in mathematics, represented by MUSA, presents this award to the professor who, in the sole judgment of the students, contributed most to their mathematical studies. I call upon MUSA President Alejandro Leyva to present this award.
Hello all. I want to start by congratulating the class of 2026 on a truly amazing journey. As part of this journey, they had to take 120 units of classes, and the instructors have a lot to do with this. One of MUSA's biggest events in the semester is our peer advising night. We have a big slideshow with all the classes, and people get together to talk about all of them and go through them one by one. Anyone that's been to that event or has just been on campus during enrollment knows the types of questions that come up. What's the grading like? Is attendance mandatory? Is this professor approachable? What's the workload? For good reason, students worry about their professors teaching these classes. So the math department, along with MUSA, take the time and effort to dedicate a special award to an instructor who excels in charge of the classroom. Starting this year, the math department has made Math 113 into a larger lecture hall style class. Because it's a required class for the major, this had a lot of students worried about getting lost in a crowd and changing the dynamics of one of the most important classes to take. These fears were quickly put to rest when Professor Gates went to the chalkboard. The students that nominated him noted that the topics chosen, the homework, the exams were all perfectly designed in order to help students understand the material. He was approachable and calm, making the big class feel personal and close. So, on behalf of the math department and MUSA, I would like to present this award to Professor Christian Gates. And no, this is not an award for the best facial hair, but it's the Distinguished Teaching Award.
Thank you, Alejandro. It is now my great honor to introduce this year's commencement speaker, Professor Mohammed Abu Zaid. Mohammed Abu Zaid is a professor of mathematics at Stanford University, working in symplectic topology and its connections to algebraic geometry and homotopy theory, and is the executive director of First Proof, a nonprofit organization which aims to understand the capabilities of AI systems in assisting research mathematicians. After earning his PhD from the University of Chicago in 2007, he was a Clay Research Fellow, was a speaker at the International Congress of Mathematicians in 2014. He received the 2017 New Horizons Prize in Mathematics, and he is a Fellow of the American Mathematical Society. Please join me in welcoming our 2026 Mathematics Commencement speaker, Mohammed Abu Zaid.
My speech is on my phone. Thank you. Dean Kahn, Professor Olson, distinguished faculty, proud families, and meritorious graduates. I am pleased to join you from the other side of the bay in order to address you on this day. On this day, when we have gathered to celebrate the efforts and achievements of this brightest cohort of young mathematicians who are receiving their degrees from one of the world's greatest mathematics departments. Whichever way your story here started, a train trip across the bay, a packed car trip across the country, or a journey across this ocean, you have earned the degree that you're about to receive through your efforts and perseverance, the least of which was climbing the steps of Evans Hall. On behalf of everyone assembled, congratulations. We also gather at a moment of unusual turbulence for our discipline. Over the past several years, machines have been built that store every formula, every equation, every theorem, and every proof that mathematicians have committed to paper. Not as a library to be consulted, but as training data for systems who are designed to recombine these results into new ones. These systems were then set to the task of taking the most challenging exams that high school students would ever take, and they managed to match the best of them. Then they were tested on undergraduate courseworks across every branch of mathematics, geometry, topology, analysis, algebra, and they performed so well that they can now be used to write the exam and the solutions. I myself have been probing with colleagues here, as well as other universities, their abilities to engage with research-level problems. In this regard, their performance continues to improve. These developments are not accidents. The AI industry has set its sights on mathematics as a domain whose high standards of rigor and clarity make it possible to demonstrate the capabilities of their products. This is certainly flattering, and it puts you at the forefront of societal changes. You will be the first to be asked whether one can trust AI. You will have to explain what you contribute beyond what the chatbots can. And you will have to lead the way in integrating these tools with your expertise. Because of this, the situation creates genuine and understandable apprehension. The fear is that mathematicians are becoming obsolete. The knowledge that students dutifully acquired over years of education now appears to be reproducible and maybe even extended by a physical device. If that's the case, what was the point? But this is not the first time that mathematicians have confronted the questions of figuring out how to adapt their training to a new environment. We may like to speak of our discipline as going back thousands of years, but reading mathematical texts older than a century reveals enormous changes. I'm a topologist. Poincaré spent far more pages developing numerical methods for almanacs than he did thinking about manifolds. Newton devoted more time calculating the position of the moon in the night sky than he did developing the theory of gravity. Al-Khwarizmi's text on algebras, if you try to read it, it's extended prose on how to manipulate what we now think of as equations, but using only verbal methods. And if you go further back in time, you will see that Archimedes resorts to very elaborate geometric arguments to describe larger numbers because he didn't have access to exponents. Changes in the outwards appearance of mathematics has been a constant feature of our discipline, and yet its core has not changed. The methods used by ancient Babylonians to find Pythagorean triples or Fibonacci's solution to specific cubic equations or explicit constructions of a regular 17 gone by Gauss, all those things are not of great interest to current mathematicians, but again, we recognize instantly ourselves as their descendants. To see why, we need to be clear about what mathematics is actually doing. The purpose of mathematics is not to accumulate facts, or theorems, or lemmas, or proofs. It is to produce languages and make it possible for the human mind to unambiguously understand both natural and artificial phenomena. Each mathematical discipline is such a language. Calculus was invented to describe the motion of objects, algebra to encode the symmetries and structures of numbers, geometry to understand the shapes around us. Building these languages is the core of what mathematicians in universities do, and applying them as new explanatory frameworks to new situations is the core of what mathematicians in industry, government, non-profits are responsible for. In this way, the languages grow, sometimes far beyond their initial domain, and so analysis becomes p-adic, algebra non-commutative, and geometry symplectic. In order to build these languages, we are thus constantly seeking to understand what is the question that we are asking, why this question, what does an answer reveal? Does the answer provide clarity on more than the initial question? If so, what should the question be? If not, is there a better answer that might reveal more? That work, the work of building new languages, is not what the machines are currently doing. What they're doing is something genuinely impressive and genuinely useful. They are making the accumulated knowledge of the discipline more accessible, more searchable, more applicable, more combinable. This is a real contribution, but it is a contribution that is alongside the contributions of mathematicians. When I state this view to those in the AI industry, they express incredulity at the claim that the capabilities of their systems might not one day grow unbounded. I'm not a seer, but this is something that I urge you to explore for yourself. While the training of a frontier LLM now costs upwards of $1 billion, their raw capabilities in just doing mathematics are really quite limited. What elicits these impressive results that we all hear about IMO problems, Putnam problems, or maybe those research problems that I mentioned earlier. What elicits these capabilities are systems that were specifically designed with LLMs as core ingredients by mathematicians for solving mathematics questions. Attempting this challenge of building such a system myself and seeing the relative difficulty of each task has made me quite skeptical of claims of endless progress, of machines working by themselves. And so I end where I started. You, our graduates today, are leading the charge in this new age, and the decisions you make are going to affect how mathematics, in the future, interacts both with technology and with broader society. Even if your instinct and your inclinations would naturally lead you in a different time away from the task I set for you, I would urge you today to start experimenting and building on the systems that have been made available to us. You would be very surprised how far $20 can go. Congratulations again.
Thank you very much. Before we go on to the main event, I would like to thank one of the many groups of people who make our commencement a very special occasion. This here behind me is the Mathematics Orchestra of Berkeley. It is directed by Maestro Michael Wong. I would like to thank the members of the orchestra for their generous donation of time and skill. Let's again express our appreciation to the Mathematics Orchestra. In a moment, we will present the degrees of Bachelor of Arts in Mathematics and Applied Mathematics. Professors Paulin, Eisenbud, Larson, Gates, Hutchings, and Srivastava will assist me in reading the names of our graduates, and Professor Bramler will present the undergraduates with their commencement scrolls. It is our custom to announce the future plans of our graduates to the extent they have revealed them to us as they come forward. Some candidates will be completing their degrees a bit later in the year and may not yet have specific plans. We will be starting with the undergraduate prize winners, and then with pure math students in roughly alphabetical order, followed by applied math students in roughly alphabetical order. Alex Paulin will begin.
David Jung, highest honors, future plans, PhD, math at Harvard. Yoon-sang Kim, highest honors, PhD in mathematics at Carnegie Mellon University. Brian Lee, high honors, PhD in mathematics. Tristan Liu, highest honors. Neil Nitin Agrawal, highest honors, PhD in mathematics. Daniel Au, high honors, graduate school. Declan Hoban, highest honors, PhD in statistics at UChicago. Trisana Bhatia, highest honors, making dozens of dollars at grad school at Brown. Sian Chen, highest honors, PhD in mathematics at USC. Jason Guo. Athreya Kadampi, highest honors, computer science PhD at Stanford, studying computational methods for biology. Jack Lipson, honors, attending math graduate school. Sushant Sathish Kumar, highest honors, software engineer. Lian Tam, highest honors, PhD in mathematics at the University of Illinois, Chicago. Ariana Abul. Ali El Mumin, becoming a professor of mathematics at Kuwait University. Ishmael Alvarez Bermudez, becoming a high school math teacher in Sacramento. Daniel Arvalo Voorhes, applied to graduate schools in mathematics in California and Spain. Nathan Barnes, honors, San Francisco State for graduate school. Kobe Bass, become a teacher in the Bay. Maya Bashu, Honours, PhD in Physics at Caltech. Graham Bates, working in software at Arc Biotech. Anthony Batista, actuarial work. Matthew Corbo, highest honours, going to law school. Marina Nicole Behar, becoming a math tutor and applied to graduate school. Cass Spigler, getting my math masters. Sambabi Bose, honours, applied to graduate school in math. Brendan Boyle, go Bears. Aaron Burnham Schmidt, PhD in math at UIUC. Tenzin Chang, applied to graduate school. Gayatri Chivulkula, congratulations. Rudy Colato, a career in software engineering. Ali Kopani, high school math teacher in San Jose. Travis Graham Dell. Zachary Dell, high honours, applied to graduate school. Peyton Ake, applied to graduate school in data science research. Thomas Files, pursuing a career as an actuary. Alejandro Flores, become a high school math teacher in the Central Valley. Laura Grimberg, honours, applied to graduate school in mathematics. Jack Hansen, high honours. Christopher Hartanto, honours, systems administrator at Epic. Cristela Kaylee Herrera Morales, pursue a PhD in mathematics. Brian Hildebrand, data analyst. Timothy Casriel, honours, PhD student. Dung Ho Kim, honours, PhD in mathematics. Kai Cooper, become a high school math teacher in the Bay Area. Avantri Kurukula Shurya. David LaRoche, honours. Cosmo Liu. Ali Ziad Lun. Apply to grad school and busk in late merit. And now my colleague, Professor David Eisenbud, will read the rest of the math students and begin the applied mathematics graduates.
Edwin Long, obtain a master's in mathematics and become an educator. Theodore Lysek, honors, PhD in math at Brown. Herman Malik, honors, a career in security engineering. Arun Manohar, PhD in physics at the University of Chicago. Alexander Migdrichian, I hope that's acceptable, working in investment management. Congratulations. Connor Vincent Murray, PhD in math. Gabriel Navarro Terrazas, software engineer at Amazon. Jennifer Negrete, become a community college math teacher in the Bay Area. Caprice Neiman, Masters in Mathematics in Los Angeles. Trustin Nguyen, software engineer. Alexander Ohava, honors PhD in math at Northwestern. Sarai Ortiz, a career in education. Kevin Peng, honors, graduate student at NYU Courant. Saili Ranapur applied to graduate school. Jose Angel Robles, working as a math teacher. Adriana Maria Sloan, become a high school math teacher in the Bay Area. Abby Smith, highest honors, PhD student at the University of Minnesota. Albert Su. Brandon Tran, software engineering and machine learning. Nicholas Trocino. There you are. Yes. Congratulations. Jordan Trong, make a Toho fan game with friends. Toho fan game. Harsha Ananth Visa, taking a gap year. Aditya Warrior. Justin Wu, highest honors, PhD in math. Natalie Yang, work in fashion. Albert Shangyun Zhang. Josh Zhang. Georgia Zhou, explore many different kinds of meaning. Yinglu Zhou, career in actuarial science or finance. Yue Zhou, pursue graduate studies in mathematics. Arhan Agarwal, research scientist in AI. Yash Agarwal, touching grass and making positive EV decisions in life. Anvin Agrawal, Masters in Applied Data Science, Carnegie Mellon University. Lucas Anderson applied to graduate school and worked for an actuarial firm. Isaiah Angelis in applied math. Remy Aquino pursuing a career in aerospace engineering. Medika Athreya, software engineer at a startup. Shashwat Bansal, a career in software engineering. Luis Felipe Barbosa, graduate studies in the intersection of media, mathematics, and technology. Dia Barot, further develop my startup and create my own company. Francis Basco, become a high school math teacher in the Bay Area. Jake Beer, intern over the summer. Caitlin Begbie, post-bac research in planetary habitability at the Space Telescope Science Institute. Aidan Cooper Bernatto, work in the pharmaceutical industry designing a medicine discovery platform. And now my colleague, Professor Hannah Larson, will continue reading the applied math graduates.
Tanya Bakri, software engineer at a startup. Anirudh Bharadwaj, work as an AI researcher. Digvijay Boki. Nur Adib Zafri bin Nur Aziz, investments analyst at Kazan National Berhad. Dulce Inez Bravo Barboza. DJ Bui, data analyst in tech with plans for graduate school. Luca Butera, working as a transportation data scientist and systems engineer for MindHop Inc. in New York, researching predictive models for traffic congestion and transit demand. Wen Cao, further studies in chip design. Lucas Keith Cardenas Scott, a career in data science. Ariana Cerrone Gomez, applied to graduate school in operations research. Sriniti Chandrasekaran, software engineer at Crusoe. Elaine Chang, a career in finance. Amanda Chen, data analytics at Stryker. Daniel Chen, become a community college math professor. Shimin Chen, applied to graduate school in financial analysis. Cronus Chang. Crystal Chang, career in software engineering. Nicholas Costello. Shannon Cudworth, geometry processing research at MIT. Amelia Davis, a career in insurance broking in Los Angeles. Pablo de la Cruz, honors, to relax. Tala de la Cruz, a career in finance. Deval Deliwala, MS in computational math at Stanford. Denise Dengi, highest honors, PhD in applied math at NYU Courant. Parth Anjali Rutvik Desai, career in data engineering. Alexis Diaz, apply to graduate school. Vidushi Divaidi, data analytics and engineering in New York City. Dylan Lee Edwards, spend time with loved ones. Yuan Egbert, a career in accounting at Ernst & Young. Jenna El Amadi, starting a career in data science and analytics. Nicholas Dominic Brogel, continue exploring passions and befriending the family dog, Romeo. Caden McManus Elstein, keep on going. Emmanuel Felix Pena. Frederia Fluker, data engineering for SF County. Maor Adam Fuchs, honors, pursuing a graduate degree in engineering. Alex Gao. Valeria Garcia Herrera, accounting and finances in alternative investment funds. Anne Pauline Garong. Eli Jandro Distler, physics PhD at Stanford, focused on astrophysics and cosmology. Charles Eric Gefeller. Christopher Weisen, a career in consulting. Samita Ghosh, software engineer at Capital One. Arijit Ghoshal, highest honors, a career in mathematics and computer science. Charvi Goyal, quant at Goldman Sachs. Edwin Gregory, a career in financial engineering. Willie Guan, software engineer in the Bay Area. And now my colleague, Professor Christian Gates, will continue reading the applied mathematics graduates.
Tiran Hajebe, a career in academia. Ayana Isadora Harris, integrating mathematical concepts into art installations. Kian Hekmatnejad, graduate school. Kita Hu, career in energy and analytics. Mark Hu, applied to graduate school in financial engineering. Haowen Huang, a career in data analytics. Xiaobin Huang, a career in quant development. Muhammad Tella Ijaz, a Master in Philosophy at Cambridge University. Harry Elayan. Junjie Jia, continue to further my master program. Eric Jiang, graduate studies in data science and statistics at Harvard. Zhifeng Jiang. Rithika Joshi, software engineer at Verdaka. Avi Judge, a career in consulting. Jimin Jung, career in actuarial science, later transition into cyber insurance. Cole Jung, master's in statistics at Columbia University. Michael Karazan. Jackie Kuh, want to get rich. Maximilian Keller, a career as quantitative trader. Madeline Kester, pursuing a career in actuarial science. Carson Kim. Heewon Kim, software engineer. Gwanwoo Kim, PhD in physics. Michael Kim. Woosuk Kim, product manager at AI and robotics startup. Yavor Tihomirov Kirilov. Catherine Kittleson, quantitative financial analyst for Webull on Wall Street. Nathan Peng Kuo, MD at Mayo Clinic, Alex School of Medicine. Ava Labmeyer, a career in data science. Jeanette Le, a career in data analytics. Nathan Liao, work on CPA license. Vivienne Lee, go Bears. Henry Lee, PhD in computer science at CMU. Jindy Lee, enjoy life. Xiaolong Li. Ava Liang, Masters in Music at Johns Hopkins University. Xiaolin Liao, actuarial or analyst career in finance. Alex Lin, go Bears. Lin Jiemi, drive and travel. Jianheng Lin. Isaac Lin. Pursue a career in finance or accounting. Yichen Liu. Building AI technology startups. Satvik Sai Lola. Machine learning engineering in the Bay Area. Jimmy Liu. And now my colleague, Professor Michael Hutchings, will continue reading the applied mathematics graduates.
Sahil Malhotra. Chloe Merrick, Masters in EECS at Berkeley. Brandon Marin, a career in data analytics. Valeria Matias, become a community college math professor in LA and give back to my community. Iason Masuris, pre-doc in economics at MIT. Charlie McDonald, highest honors, software engineer for AI safety. Ian McClellan. Brian Munn, quant trader. Juanbo Meng, graduate studies in computational and mathematical engineering at Stanford. Samantha Norika Meng. Arnavi Nagamuli, Masters in Statistics and Data Science. Luna Nam, go Bears. Alexander Quinn Nicholson, unsure yet, possibly teach high school math. Mataya Nonaka, honors. Alden Au, pursuing a future through lifelong learning and community service and growing with the changing world. Annie Pon, pursuing a career in actuarial science. Ellen Papian. Itash Tripathi Patel, honors, research at LLNL, hopeful future PhD student. Orlando Pereira, go Bears. Phoenix Pham. Vrushank Prakash, software engineer at Amazon. Tilo Pricer. Carolyn Chan. Ryan Wren, AI engineer in FinTech. Ana Caterina Quartiero, continue to pursue education in Singapore. Tanya Lizette Rodriguez, teach math and become a certified actuary. Alejandro Romero, a career in consulting or finance. Sarah Salamula, a career in consulting or finance. Angel Salazar, become a corporate lawyer. Nina Schmidt, a career in actuarial analysis. Ayushi Shah. Xiaolin Shao. Sabine Shashati, applied to graduate school in financial analytics. Rohan Shenoy, pursuing a PhD in computer science at the University of Pennsylvania. Vladislav Shevkunov, a career in quantitative finance. Vinay Somawar, entrepreneurship. Sean Soley, specialist at Snowflake. Jay Sonawala. Anirudh Srirama. Shersti Yuli Stulam. Dagny Streit, technology investment banking analyst. Brandon Su, go Bears. Brian Sway, go Bears. Jialu Sun. Catherine Tan, software engineer at IXL Learning. Xuanwen Rebecca Tan, a pre-med student while keeping math as a lifelong hobby. Gloria Tao, software engineer at AWS. And now my colleague, Professor Nikhil Srivastava, will finish reading the Applied Mathematics graduates.
Aren Telemi. Baiza Nur Tepekos. Kanan Tu, MS in Applied Statistics at Pomona. Ton Tran, data engineer at Mercer. An Chuang, a career in the tech industry. Kayleen William Twangara. Aisha Shireen Umar Malik, pursuing a career in data science. Benji Van Linden. Vidya Venkatachalam, research fellow in empirical law and finance at Stanford. Dia Vij, work at a startup in San Francisco. Vishal Vijay, software engineer at IBM. Hurant Verobion. Cameron Virgin, highest honors, PhD in applied math at Cornell. V. Walia, reaching for the stars. Jun Jae Wong, data science related career. Ching Wei Wong, off to change the world or my corner of it. Raymond Lee Wong. Elizabeth Warren, joining the Aerospace Corporation as a spacecraft materials engineer. Erin Wong, applied to medical school. Gigi Wu, looking for a nice job. Athena Xia, a career in finance. Nair Xia will continue learning in Cornell Tech. Patrick Shu. Yujia Shu. No matter what, be a memory no one forgets. Hong Chen Yang. Future is independent of the past, given the present. Go Bears. Jack Young. Continue to work in the Bay Area. Jerry Young. Maxwell Young, career in aviation. Morris Young, applied to graduate school in statistics. Bennett Yarnell. Addison Ye, M.Eng in computational mechanics and scientific computing at Duke University. Nick Yin, gradient ascending. Yuan Ying, applied to graduate school in data science. Junwei Yu, computer vision researcher. Shuo Yuan, keep studying EECS at Berkeley. Yu Guo Tang, software engineer at Databricks. Pune Zetabfat, PhD at Yale, studying cosmochemistry. Wan Tong Charlotte Zhang, proudly a woman in tech, creating possibilities with boundless curiosity. Junyu Zhang, math career while pursuing pilot training. Meng Zhang, pursue a career in software engineering. Xiuwei Zhang, explore the world through a mathematical lens. Fangzhu Zhou, pursuing a master's degree at UCSD. Jennifer Zhao, honors. Wesley Kai Zheng, fifth year MS in EECS at Berkeley. Jihei Zhou, seek for life purpose. Jian Zhu, become a high school math teacher in the Bay Area. Timothy Bergal, MA in mathematics at University of Wisconsin-Madison. Jacob Martin, learning Mandarin in Shanghai.
Will the bachelor students please stand? Graduates, you may now move the tassel on your cap from the right side to the left. We now proceed to award the degree of Doctor of Philosophy. You may be seated. The PhD is the highest academic degree that can be achieved in mathematics. It represents years of dedicated scholarship, mastery of the subject, and individual originality and creativity in a new contribution to knowledge. It is my pleasure to call forward the candidates who have earned the right to be called doctor. Will the candidates for the degree of Doctor of Philosophy in Logic and the Methodology of Science, Mathematics, and Applied Mathematics please come forward? Professor Scanlon will assist me, and the PhD advisors, if they're here today, will hood their students.
I will start with the candidates for the PhD in Logic and the Methodology of Science. Jordan Brown, with a thesis on variational problems in learning theory. His advisors were Antonio Montalban and me, and I'll hood Jordan. Ronan O'Gorman, with a thesis on group chunks in model theory and algebraic geometry. It's advised by Martin Olson and me, and both of us will hood him. Next are the candidates for the PhD in mathematics. Catalin Berlo, who wrote a dissertation on descriptive combinatorics of grids, advised by Andrew Marks and Robert Tucker-Drob, will be hooded by Andrew Marks. Garrett Brown, who wrote a dissertation on scalar curvature under blow-up and positive scalar curvature Kähler surfaces, advised by Richard Bamler, and Song Soon will be hooded by Richard Bamler. Fanggu Chen wrote a dissertation on infinitely many supersingular primes for some abelian varieties. We hooded by our advisor, Yunxing Tong. Isabel Dethridge wrote her dissertation on spectral problems and probabilistic techniques. She's been hooded by her advisor, Nikhil Srivastava. Jacob Elefandi, whose dissertation is on finite element analysis of models of pneumatic liquid crystal dynamics. It's advised by Franziska Weber and will be hooded by Per Olaf Persson. Carlos Esparza Sanchez, with her dissertation on some results on non-compact Kähler-Ricci shrinkers, is advised by Song Soon and will be hooded by Richard Bamler. Yuicheng Feng has a dissertation on constructions of contact scalar curvature Kähler metrics of Poincare type, be hooded by our advisor, Richard Bamler. Hanna Friedman, the dissertation on metric algebraic geometry of Grassmannians, is advised by Bernd Sturmfels and Serkan Hoshton, be hooded by Bernd Sturmfels. Sean Gonzalez has a dissertation on Strata-Hassan variants on proper abelian type Schmür varieties, be hooded by his advisor, Sugbu Shin. Connor Halleck Dubé. It's a dissertation on the cohomological weighted fundamental lemma for non-split groups, will also be hooded by Sugbu Shin. Mitsuki Hanada is a dissertation on catabolism and tableau combinatorics of generalized coinvariant rings. She's been hooded by her advisors, Mark Hyman and Sylvie Courtel. Xiaoyu Wang has a dissertation on vortex filament dynamics and the 3D incompressible Euler equations, be hooded by his advisor, Daniel Tataru. Zhen Wang has a dissertation on low scaling algorithms for quantum mini-body physics, be hooded by his advisor, Lin Lin. Daigo Yito wrote a dissertation on geometry in the triangular spectrum of perfect derived categories, advised by David Nadler and will be hooded by Martin Olson. Eric Jonkowski wrote a dissertation on the supercombinatorics of toric supervarieties, advised by Vera Sarganova, and will be hooded by Sylvie Courtil. Sibu Lee wrote a dissertation on positive quasi-modular forms and linear programming bounds, will be hooded by his advisor, Sugbu Shin. John Robert Lentfer wrote a dissertation on combinatorics of bosonic fermionic covariant rings, will be hooded by his advisors, Mark Hyman and Sylvie Courtil. Fei-Young Lin wrote a dissertation on the geometry of splitting loci. She'll be hooded by her advisors, Hannah Larson and David Eisenbud. Rose Eleanor Lopez has a dissertation entitled Picard Groups and Brouwer Groups of Certain Stacks, advised by Martin Olson and Sugwo Shin, and will be hooded by Martin Olson. Yuchen Mao has a dissertation entitled Initial Data Construction and General Relativity, will be hooded by his advisor, Sung-Jin Oh. John Stephen Nolan wrote a dissertation entitled Derived Toric Geometry and Quivered Tensor Products, will be hooded by his advisor, Konstantin Telemann. Elizabeth Pratt wrote a dissertation entitled Positive and Projective Geometry. They've been hooded by their advisor, Bernd Sturmfels. Abby Rajan wrote a dissertation entitled Expanding Ricci solitons and the Expander Degree. It's being hooded by his advisor, Richard Bamler. Ellie Sandin wrote a dissertation on Hunter-type gravitational collapse profiles for the Euler-Poisson system. It's been hooded by his advisor, Sung-Jin Oh. Andrew Scharf wrote a dissertation entitled Modeling of Poroelastic Plates in Fluid Structure Interaction Problems, advised by Sunchicha Chanitz, and is being hooded by Sung-Jin Oh. Zachary Steer wrote a dissertation entitled Algorithms and Spectral Gaps for Quantum Problems. He's been hooded by his advisor, Nikhil Srivastava. Svala Sverrisdottir wrote a dissertation entitled Nonlinear Algebra and Quantum Chemistry. She's being hooded by her advisor, Bernd Sturmfels. Pranav Rajesh Trivedi wrote a dissertation entitled Quantum Hierarchical Locally Recoverable Codes. He's being hooded by his advisor, Venkat Guruswamy. Enoch Yu wrote a dissertation entitled Modeling Rosansky-Witten Theory with Sheaves of Categories. Advised by David Nadler, he's being hooded by Konstantin Telemann. I will finish with the candidates for the PhD in Applied Mathematics. Yuhong Kai wrote a dissertation on mathematical foundations of modern machine learning and scientific computing, multimodal pre-training, implicit bias, and stochastic density functional theory. Advised by Michael Lindsay and Peter Bartlett. It's being hooded by Lin Lin. Louis Pan wrote a dissertation entitled Fast, High-Order Discontinuous Methods for Computational Fluids and Quantum Chemistry. Advised by Paralov Persson and Michael Lindsay. He's being hooded by Paralov Persson.
Will the PhD students please stand? Family and friends, once again, please join me in congratulating our new doctorates. As we close this portion of today's program, I would like to thank the many people who helped make this such a fine occasion. Again, I wish to thank the Mathematics Orchestra at Berkeley under the direction of Maestro Michael Wong. Michael, please take a bow with your players. I thank the faculty and students of the math department, without whose hard work we would have nothing to celebrate here. I would also like to thank the staff of the mathematics department. Our students know how important the staff is to the sense of community in our wonderful department, and I would like to reaffirm this importance to everyone here. I will now ask the audience to stand and to please remain in your places for the recessional. Once again, let me congratulate our graduates.